All right, we got 5.4, the sine, cosine, and tangent ratios here. Basically, this whole lesson is going to be about if I give you a side and then an angle, we're going to go and find the other missing sides of a triangle here. So it's a little bit different than the 45, 45, 90, and 30, 60, 90 triangles where I gave you specific degrees and then there's a certain ratio between the sides every time. These are all kind of just random and all of that. So we're going to use our calculator to do this. We're going to use the sine, cosine, and tangent buttons in our graphing calculator. By the way, I'm using the Calculator X84 app if you want to use that to type out some of the things into your calculator. The phone calculators don't work as well because it doesn't do certain things. So you can still do it with the phone calculator. It's just a little bit more involved. So anyways, first thing we'll talk about here are the different ratios. So you have the tangent ratios, the sine ratios, and then the cosine ratios. All right, so usually you just pick an angle to look at here. So like if we're starting here at angle A right there, you're going to pick the tangent ratio. We're going to say is a ratio of the length of the opposite leg to the adjacent. And that's kind of the key things I would highlight here. It's opposite over adjacent right here. So, you know, if for example here this side was 5 and then the adjacent side here was 10, you would say the tangent ratio is 5 over 10. Okay, and you can do that from any of the acute angles. So you could also go and look here at angle B. It's still the same idea of opposite over adjacent. But if I had those 5 and 10s in different places, it would be 10 over 5 would be the ratio there of the sides. So I'll show you an example here in a minute what that's going to look like. Really the big takeaway from this section here is figuring out what goes with what here. Next, right here, we have the sine ratio. It's abbreviated SIN. And that's going to be opposite over hypotenuse. And then you're going to have the cosine ratio. It's abbreviated with COS. And that's going to be the adjacent over the hypotenuse. Okay. Now, as far as how to label the triangle, I'm going to start here with angle A. And if we're doing this with respect to angle A, the side across from it, that's the side we're going to call the opposite. The hypotenuse is always going to be the side across from the right angle, so the longest side right there. And then the remaining side, we're going to call that the adjacent side right there. And that's how you're going to go and label your triangles for those. So we'll see some here in a minute where we will actually like do some ratios and stuff like that here in a second. Before we do that, we want to also make sure you know how to type certain things into the calculator here. So down here we're going to use the calculator to find each of these values. Big thing with the calculator is you need to make sure it's in degree mode. There are two main settings that are used on a graphing calculator with dealing with angles. And then there's another thing called radians. So we need to make sure we're dealing with angles. We're going to hit the mode button right up here next to second. And then you're going to find where it says angle versus degree. So that's kind of right there, a couple of clicks down on the calculator. I think it's 4 or 5 options down. But make sure degree is selected. If you're on a TI-84 calculator, highlight degree, hit enter, and then you can hit second mode to back out that screen. And then I guess we're going to do tangent of 31. So we find the tangent button. It's right there. And then you type in the 31 degrees right there. You don't really need to put a degree symbol. I don't even think you need to close the parentheses. And we're going to round to the nearest 10,000th. So I believe that is 4 decimal places there. So that would be 600. Since we have an 86 there at the end, that means we're going to round up to a 9. So 6.6009. And then if we want to do cosine of 56, kind of the same thing, you type it in. We're going to go out 4 decimal places again. So 555, 9, and then it's 19. The 9 will round us up to a 2. So basically with rounding, don't forget if the number, I guess if we're rounding to the 10,000th or the 4th digit, the 5th digit, if it is 5 or bigger, you will round up. And then if it is 4 or smaller, you'll keep the number the same. Sine of 31 degrees, it's going to be 0.515 5, and then 0 will just stay 0 since it rounds down. So that's just typing in the things right there. So apparently there's some type of fraction that comes out pretty close to 0.6009 right there. That matches with the 31 degrees. But we'll get to that here in a second. To work backwards for the angle, we're going to hit the second button on these here. So this will be second tangent, and that'll look kind of like this right here. It'll be tangent. It looks like it's raised to -1. That's just called the inverse. So tangent inverse, and then we're going to type that decimal in. And this will work backwards for the angle. So you hit second tangent 0.6832. And that's about 34 degrees, and they want us to round to the nearest degree. So yep, 34 degrees, and then put a unit right there. The unit is the degrees. Okay. As far as the sine of 0.34, we'll do second sine, because we're working backwards for an angle of 0.34. And that's about 19.8 degrees right there, so technically that rounds up to 20. So we'll say that rounds up to 20 degrees. And then let's see here, cosine of the fraction 5/7. So second cosine, and then we'll just put the fraction 5/7. Just like that right there. And that gets us about 44 degrees. So that's how you type those into the calculator. Next, we're going to work on setting up ratios, and then we're going to use these ratios to go and solve for x or some type of missing side or sometimes an angle. Before we do that here, to figure out which sides match up, there's kind of a little saying you might hear sometimes here. So here's your saying. They call it Sohcahtoa. It's a little acronym here. All right, and Sohcahtoa right there helps us relate all the different things here. So the sine function, and that's why it starts with an S right there, the sine function of an angle, I'll just call it angle x, equals the opposite over the hypotenuse. That's what the so part means. The one starting with C is called cosine. The cosine ratio is the adjacent over the hypotenuse. And then the tangent ratio, the one starting with T, tangent of an angle equals the opposite over the adjacent. Right there. So I would write that down right there, Sohcahtoa. I usually encourage my students to write that down at the top of every page so they can refer back to. So once you get that, I'm going to go ahead and just rewrite it right here real quick. Sohcahtoa, and then we're going to use that idea here to go and find the tangent ratios, I guess, of these figures right here. So we can do that. And actually, you know what? I might add in sine and cosine as well, just for fun here. So anyways, if we're doing the tangent ratio of angle A, here's how you'll start this. You'll highlight angle A. You're going to label your opposite and adjacent sides. And then, of course, the 5 is the hypotenuse. And since tangent is dealing with O and A, we're going to say tangent of the angle A is going to be the opposite over the adjacent. So that would be the fraction 3/4. Okay. Now just for fun here, I'm going to add this as well. Let's go find the sine of angle A and then the cosine of angle A as well. And get those answers. So sine is dealing with the opposite and hypotenuse. So you're going to choose the opposite and hypotenuse numbers and make that into a fraction, 3/5. Okay, and then the cosine is going to be using the adjacent and the hypotenuse. So you use both of those numbers. Here's your adjacent down there, that's 4. Your hypotenuse is 5, so we'll write that as 4/5. Okay. And then when we go and look at angle C instead, that's going to change some things here. So if I'm looking here at angle C, the opposite and adjacent now are no longer what they were right there. The opposite and adjacent is going to now change. The opposite is now 4, and then the adjacent is now 3. So that's going to change some of the fractions here just slightly here. So when I'm doing the tangent, looking back up here at my little cheat sheet thing, I guess. Tangent is dealing with opposite and adjacent. So you put the opposite over adjacent. That's going to be 4/3. So basically, it was that same fraction but flipped. Sine of A is dealing with, if we're looking at our chart, that's dealing with the opposite and hypotenuse. It's going to be the 4 and 5. And then, of course, you got cosine of, oh, you know what? I'm putting the wrong angle there. It should have been sine of C. Okay, but then now cosine of C, cosine's dealing with A and H. So that is the 3 and the 5. And that's how you're just going to go and do those. So I did want to work one of those out just so you had them right there. I'll probably add sine and cosine to this next example as well. So you just write them out as ratios, and these ratios will help us here in a second solve for missing sides. Let's look here at this next one here, and just like before, I'm going to add sine and cosine. This time, hopefully I'll write it correctly here. Okay. Yeah, I was just looking at my picture, making sure we're good. Cosine of C. Alright, so starting here with angle A, if we do that, the hypotenuse is always the longest side, so I'm going to put an H there. The opposite is this 24, and then of course the adjacent down there for AB. Okay, tangent is going to be the TOA part, so that's O and A, so that's going to be the fraction 24 over 10, but that does reduce. Those are both divisible by, I believe, 2. So actually for your final answer, I want 12 and then over 5 right there. So I just divided both the numerator and denominator by 2. So make sure you do that. Make sure you always reduce like it says up here. Okay, if we use sine, sine is dealing with O and H. So that's going to be 24 over 26. You can reduce in your head right away if you want. I'm going to write it out so you know where it came from. But divide both of those by 2 and it's 12 over 13. Okay, and then of course cosine here at the end, that's the one dealing with A and H. That would be 10 over 26, which is going to get us, when that simplifies, 5 over 13. And that'll be it there on those. And then when you go and look at angle C, of course that'll be a little bit different here. That's going to change where O and A are. So you might need to go relabel and erase. And then O and A, so let's see here, tangent is O and A, so that's 10 over 24, which is going to be 5 over 12. Okay, the sine function, the sine one is going to be the opposite in hypotenuse. So that'll be 10 over 26. That'll be 5 over 13. So I didn't write out the first fraction, but you would write out the first fraction and reduce. Cosine would be the adjacent over hypotenuse. That's going to be 12 over 13 after you reduce. So that's how you set up a ratio, and we can use these ratios to go and solve for missing sides, and that's exactly what we're going to do here on this next one. Okay, so let's try out this one right here. So usually these will be how a typical trig problem starts. They'll give you some type of angle. You'll go label your sides. Here's your opposite. This one's your adjacent, and then of course the hypotenuse is the longest side. And we're going to solve for whatever W is. So this one's dealing with tangent because it's got an O and an A. So I'm solving for O eventually, but then I'm going to use the A to help myself. So that tells me, okay, we got to use tangent. We're always going to put the angle next. It's tangent of 54 degrees. And then we're going to have the fraction equals W and then over 10. And then the big idea here, so I'm going to rewrite it over here just so I got some room to work with. To solve this right here, I'm going to treat tangent of 54, I'm going to write it over 1, and then I'm going to go and cross multiply. I'm going to multiply the two diagonal things. I'm going to do 10 times tangent of 54, and then 1 times W, which equals W. And then theoretically, you would divide, but you're not going to divide by, 1. So that's actually what we're going to type into the calculator. W apparently is 10 times tangent of 54. And this is all you need to do. You type in 10, you find your tangent button, you do 54 degrees. You don't need to type the symbol there. And then apparently W is about 13.76 right there. And they want us to round to the nearest tenth. So that would be 13.8 after I round. And that's what W is. That's how you're going to go and do these. And then you can put whatever units you are. I guess we don't have units, so I'll put a U. As far as what is calculator ready, that's what you're typing into the calculator. So I typed in 10 times tangent of 54. And that's how you're going to do your trig problems there. So set up your ratio, cross multiply, divide if necessary, and then you'll type that in. Make sure, once again, want to reemphasize, make sure your calculator is set on degree mode. Otherwise, you're going to get some crazy answers that don't make sense. Okay, so hopefully you remember to do that there. Okay, let's do another one. This one's also going to deal with the tangent ratio, but the work towards the end is going to be slightly different. So let's label the opposite, adjacent, and the hypotenuse sides. We're going to use the opposite side since they gave it to us, and then we're going to also use the y side or the adjacent side because that's what we're trying to find. And that, once again, O and A is dealing with tangent. So your calculator, or I'm sorry, the tangent ratio would be tangent of 28 degrees and then equals 1 over y. Then we'll go ahead and write that. Now, like before, I want you to write that over 1, and then we need to cross multiply and divide. This will be y times tangent of 28 equals 1 times 1. So y times tangent of 28 equals 1 times 1, which is 1. And then this one's a little different because I can't really type in the y into the calculator. So what we'll do is actually divide both sides by tangent of 28. Okay. Tangent of 28 is just some decimal, so it's like some decimal times y equals 1, and we're just dividing by that decimal. And that'll get us y equals, and this is calculator ready form, 1 divided by tangent of 28, and then we'll write what that approximately is here. So you just type in, it'll be 1 divided by, and then tangent of 28 degrees, and then close your parentheses, and roughly 1.88 or 1.9 after you round. And that's going to be it there. Now, some people will be able to skip a couple of steps and write out their ratio and then get to their answer right away, or their calculator form right away. There's patterns there. I'm going to do a couple more, and then hopefully we start seeing some of the patterns, and then maybe that'll speed up some problems here towards the end. But let me do a couple more, just working it all the way out here. So we'll try that out here now. So next one right here is just a different category of questions here. Now, instead of the tangent ratio, I think we use sine and cosine here. So we'll start out the same though. We'll label our angle. We'll label our sides. Here's your opposite. Here's your adjacent. And then there's your hypotenuse. And since we're trying to find x, that's going to use the O. Since we're given 12, we're going to also use the h. And if you look at Sohcahtoa at the top, the one dealing with O and H is actually the one that starts with the S. That's going to be sine. So we'll write this as sine of 21 degrees and then equals the opposite over the hypotenuse, or in this case, x over 12. So sine of 21 equals x over 12. You can write 21 over 1, and then you can cross multiply again. That'll be 12 times sine. It's good to, whatever you're multiplying by, it's good to put that number out in front. Because if you don't close the parentheses when you're typing everything in, that's going to mess you up there. And that's actually your calculator ready form right there. 12 times sine of 21 degrees. And then we'll just type that in. 12 sine 21, and apparently about 4.3. Okay, let's do one more, and then we'll talk about the pattern here with as far as the solving piece goes here. So label your angle again, there it is. Label your sides that are opposite, adjacent, and then the hypotenuse has got to be the longest. Okay, this one is, we're given the A and we're trying to solve for the H right there. So that one is going to use the one that starts with the C. That one's going to use cosine. So it'll be cosine of your angle 28 degrees. And then I'm going to put, whoops, it needs to be adjacent over hypotenuse. So this is going to be 10 over x. Okay, and then we'll cross multiply and divide. This will be x times cosine of 28. And then equals 1 times 10. And then I want you guys to divide by cosine of 28 to get x by itself. So 10 and then divide it by cosine of 28 degrees. And that is x is approximately, here I'll put it over here, 11.3 after you round. The trig equation was what I had written as my top step right there. Cosine of 28 equals 10 over x. And then the calculator ready form was 10 divided by cosine of 28. Now I want to see if we can start making a pattern, or start recognizing, I guess, a pattern here going on with some of these here. Whenever you have your equation, your ratio right here, and notice that the variable is on the top. Notice that you multiply. You multiply both sides by 10, I guess. Notice when the variable was in the denominator or the bottom right there, we had some type of division. And we're dividing by tangent. So we're either going to multiply by tangent or we're going to divide by tangent, one or the other. And that will hold true to any of these right here. Look at this one. If x is in the numerator, we're doing multiplication by the sign. So that was multiply. Notice on this next one, if x was in the denominator, we did some division. We divided by cosine. That could speed up the problems a little bit on the solving there. Some people can just write out the ratio and then figure out what to type into the calculator right away. Okay, now at the beginning of the problem, or the day, I guess, we were talking about how to solve for angles when you don't have an angle, and we used the second button into the calculator. So those are called inverse trig functions. But basically that just means hit the second button. So I'm going to write it out as inverse trig functions. But y'all need to know it as just hitting the second button and then typing it into the calculator. So let's see what that's going to look like here on these next two. So the equation will look slightly different here. This time we don't know the angle. We'll just call it x for now. But we do have the opposite, adjacent, and hypotenuse side still. And then we can go and write our equation like this right here. It's just going to be tangent. Since O and A, if you need to write Sohcahtoa again, you can. So that's O and A, so that's tangent of angle x degrees. And then equals 6 over 8, or O over A. Now you can reduce if you would like, but you don't necessarily need to. You can just type into your calculator. We need to hit the second button. And that's going to be the tangent inverse, which looks like it's raised to -1 like that. So let's try that out, and then round to the nearest degree. So yep, we'll go second tangent, and then 6, or if I type it in right here, 6 divided by 8, and then apparently about 36, and rounding up, that'd be about 37 degrees. And that's going to be it there on those. So you just basically hit the second button and you keep it going. Alright, next one here, find the value of x to the nearest degree. So kind of the same thing here. Here's your angle. Label your opposite, adjacent, and hypotenuse. This one's using A and, oh, you know what? I labeled that wrong. Hypotenuse needs to be on the right angle, or across from the right angle. So I'm going a little too quick. Hypotenuse is always the longest side or across from the right angle. And we're going to use O and H this time, so that's the sine function. That'll be sine of x degrees equals 6.5 or 6.5, and then over 10. And then we'll hit the second button, which will look like this in the calculator. And then we can go get our decimal. So second sine 6.5 divided by 10. And then about 40, we'll call that 41 degrees. Yeah, and then after this here, it's just going to get kind of repetitive. You can kind of go through and do some of the same things. Some of these here are going to ask us to solve for multiple sides and stuff like that, but it is repetitive here after this here. So I'm still going to go ahead and work through them if you want to follow along, but you do have enough information now to complete the homework and stuff. So I'll go a little bit quicker here. Here's your opposite, adjacent, hypotenuse sides. You're using O and A, that's going to be your tangent function. So that'll be tangent of 56 degrees, and then that'll be x over the 25. All right, our shortcut that we talked about on the previous page said if x is in the numerator, then we multiply. It'll be 25, and then you'll multiply by tangent. 25 and then times tangent of 56. And apparently that is 37. Let's see what they want us. If we're doing a side length, so that's nearest tenth. So we'll say 37.1. All right, number 2, label your angle. There's your opposite. Here's your hypotenuse. Your adjacent down there at the bottom. You're using O and H this time. That'll be the sine function. That'll be sine of 21 degrees. Then equals 12 over x. X is in the denominator, so that's going to be 12 divided by sine of 21 into the calculator. 12 divided by sine of 21. You can still work it out with the cross multiplication if you don't want to memorize the rule, but it might save you a little bit of time if you memorize the rule right there. So that's 33.5. And one thing I want to emphasize here on this too is notice that we solve for the hypotenuse, and notice 33.5. That's way bigger than 12. We know the hypotenuse needs to be the longest side, so make sure you're getting a truly longer side. If not, then we probably didn't set it up right or we didn't solve it right. Okay, number 3, this one's kind of interesting because you have 2 angles that you can pick from here. You can either pick the 65 degrees or the 25 degrees. So I kind of was looking at the 25 first, so I'm going to use that. Based off of the 25, if we use the 25 degrees, then the opposite side needs to be across right there, and then the A is that 48, and then the hypotenuse is over here. And I guess we're solving for x, and then we're using the A. That's going to be the tangent function once again. It's tangent of 25, and then equals x over 48. X is in the numerator, so we would need to multiply both sides by the 48. And then you get 22.4 after you round up. So yeah. All right, a couple more here. I guess I got 2 more. I got one here at the end where you actually solve for both x and y, but we'll get to that here in a second. This one here, that's the adjacent side. Here's your hypotenuse. You're not using the opposite side at all, but since you're using A and H, that's a cosine function. Cosine of 57 degrees, that's going to be x over 24. X is in the numerator, so multiply. 24 times cosine of 57. Apparently about 13.1 unit. And that's how you're going to leave that one. All Alrighty, and then just a couple more here. So 5, notice on 5 you're actually solving for an angle. You still label everything the same here, opposite, hypotenuse, the adjacent's up there at the top. The adjacent won't get used here on this problem. O and H uses the sine function. So we'll say sine of x degrees equals 6.5 over 10. Felt like we did one pretty similar here to this. Maybe we've already done this one, but anyways, then we'll go second, I guess sine of 6.5 divided by 10 to go get the angle. That was about 40. Let's see, what do they want us to round to on these? Nearest degree for angles, so we'll call that 41 actually, if we round up. Oh, the calculator ready, forgot to write that. Sine inverse of 6.5 divided by 10. Okay. Now the only other thing that's really different here on 6 is instead of solving for one side, you're going to actually solve for both missing sides. So we'll need 2 trig equations to go get the individual x and y. So we'll label here, you have the opposite adjacent, and then the hypotenuse is down there at the bottom. The hypotenuse can be anywhere. It can be on the top or bottom of the triangle. Okay, so you pick which one you want to solve for first. I guess since they have x first, we'll solve for that. That's using the O, but you must also use the 10, which is with the A. Okay, can't really use O and H quite yet because we don't know what H is yet. So we have to use O and A. O and A, that's going to be a tangent function again. We'll say tangent of 40 degrees, and then equals the opposite over the adjacent. X is in the numerator, so that's multiplying. And then apparently we get about 8.4. And then now to go and get the y variable here, you're going to use the h, but then I would go back and then use the 10 right there. You could technically use the x that you just found, but we don't know, like if you don't know if that's right, if you mess up x, then you're automatically going to mess up y. So I would make sure to use the original sides that they gave you here, okay, which is 10, or in the adjacent, and then the hypotenuse. That'll use the cosine function. So we'll say cosine of 40 degrees, that's 10 over, I guess, y, and then since the variable's in the denominator, we'll divide. That should be 10 divided by cosine 40. And then about 13.1. And that makes sense with our picture because y is a hypotenuse. That should have been the longest side there. All right, that is it here for today.